A small quark with an excess charge of 4 microcoulombs is placed 15 centimeters from another quark which carries a charge of negative 6.2 microcoulombs. A. What's the magnitude of the electric force between the quarks? B. Is this force attractive or repulsive? C. How many excess electrons are on the negative quark? Okay, let's draw a picture. So we've got a quark over here, and then another one over here. And they're 15 centimeters apart, 1500ths of a meter. And we know that the first quark has a charge, remember Q is charge, of 4 microcoulombs. And the second one has a charge of negative 6.2 microcoulombs. Okay, what's the magnitude of the electric force? Well, as part A, electric force is the symbol force with a little subscript E for electric. And we have an equation for that, Coulomb's law, which we take the constant times charge 1 times charge 2 divided by the distance between the two charges squared. So we can go ahead and start substituting in what we've got. We have to be a little careful when we go into this equation, though. We need to make sure that we are in the right units, okay? So our charges need to be in coulombs. So we've got our constant, which is 8.99 times 10 to the 9th. And then we've got our first charge, which is a positive 4 microcoulombs. Remember, micro means times 10 to the negative 6. So this is 4 times 10 to the negative 6 coulombs. And then we've got the second charge, which is negative 6.2 microcoulombs, again, times 10 to the negative 6 to get it to be in coulombs. Now you're going to notice I didn't put the negative in. The negative with these charges doesn't tell us which direction the charge is going. It just tells us its type of charge, positive or negative, and then we can look at the two and say, hey, these are opposites, they should attract, or if this was also negative, they're the same charge, so they would repel. So we're going to leave the negatives out of the equation and then just look later to see what's happening. And then we divide by the distance between the two squared, which is 1500ths of a meter squared. Okay, substitute that into our calculator, and we will get the electric charge to be 9.91 newtons. Now, if you'd left the negative in there, this would be a negative number, but that negative wouldn't tell you the direction because they're not both going to go to the left. Usually negative meant left or down. They're not both going to go down. They're going to go one to the right and one to the left. So that's, again, why we're leaving the negative out. It's just 9.91 newtons, and then if we are talking about the charge about the force on the first charge, well, that's 9.91 newtons to the right. If we're talking about the force on the second charge, it's 9.91 newtons to the left. So you have to get the direction, you have to be specific about which charge you are looking at. Okay, part B, answered this already a couple times. Is the force attractive or repulsive? Well, they're opposites, so it is attractive. And then part C, how many excess electrons are on the negative quark? Okay, electrons have a negative charge, and this has a negative charge overall, so there must be more electrons than there are protons. So now we need to see how many more. Okay, well, we know that an electron has a charge of negative 1.6 times 10 to the negative 19th coulombs. We also know that our charge 2 has a magnitude of negative 6.2 times 10 to the negative 6 coulombs. Okay, remember micro, 10 to the negative 6. I want to know how many there are. Well, if we let n be the number of electrons, if we take the total and divide by how much charge each one has, we're going to get that number. So I take the total charge divided by the charge on an electron of 1, and that'll give me the number. So I'm going to have negative 6.2 times 10 to the negative 6 divided by negative 1.6 times 10 to the negative 19. And I'm going to get that there are 3.875 times 10 to the 13th excess electrons. So there are this many more electrons than there are protons on this quark.